like to show to you is the stool culture. A very, very common specimen ordered in the lab. In the stool culture, we're using different types of media. We're going to start McConkey, as what you already know. And here again, for stool, we're looking for Salmonella and Shigella. Salmonella and Shigella do not ferment lactose. And so, in this case, since they do not ferment lactose, you'll see them as colorless colonies, not pink colonies. In other words, this culture, this stool culture, does not have any Salmonella or Shigella. Then, besides that, we use what we call a Salmonella Shigella agar. Salmonella Shigella agar has also lactose in it. And not only that, it has ferric chloride in it that turns black if you have Salmonella. The colonies will literally turn black in color. And of course, Shigella is going to be a non-lactose fermenter, so it will be colorless. And Salmonella most of the time will turn black because of the hydrogen sulfide production. The next is the blood agar plate. We just use the blood agar plate for organisms like Aeromonas and Vibrio. Like Vibrio alginolyticus grows very well on a blood agar plate. Looks like pretty much like Pseudomonas. The next one that we're using is also the XLD agar. Xylose, lysine, the desoxycholate. Now, as you can see, we're using several different agars so that we don't miss the Salmonella and Shigella. Now, the reaction here, if it's yellow, that means it's a lactose fermenter. If there is Salmonella in here, the Salmonella is going to use the lysine and it's going to increase the pH. Then because of the phenol red indicator in here, increase in pH is going to make the colony red. And so it happens that here you don't have any red colonies, so I would say right away that these are just the usual flora of the stool, lactose fermenters. Next one is called SMAC. SMAC is called sorbitol McConkey agar. Sorbitol McConkey agar works pretty much like McConkey, except instead of lactose, it has sorbitol. Now, the reason why we're using this is because we would like to make sure that the patient does not harbor any E. coli 0157H7, which is, as you all know, is a very, very pathogenic and lethal organism, much worse than Salmonella and Shigella. The E. coli 0157H7 will produce a colorless colony on the SMAC. The other E. coli will be able to. So what you're talking about is the gut flora will ferment the sorbitol. That's why you have the gas that you're talking about. Together with the stool culture, we're also inoculating the stool in what we call GN broth. GN broth is enrichment and a selective medium at the same time. After inoculating this, we incubate it in the incubator at 35 to 37 degrees. Then we subculture this, because if there are some Salmonella or Shigella in here, what happens is Salmonella and Shigella overgrow the rest of the Enterobacteriaceae just after 8 hours maximum, and after that the Salmonella and Shigella will be overgrown by the ordinary Enterobacteriaceae. Gram-positive organisms will not grow in the GN broth. After 6 to 8 hours of incubation, we subculture it into a McConkey agar and a Salmonella Shigella agar. So that if there is something that we miss from the original Stool culture, we're not going to miss it from the GN broth.
So you amplify the number.
We amplify the number. There
Okay.
we go. Thank you so much. Yeah. With this, we just don't throw it away after subbing it to another McConkey and Salmonella Shigella agar. We also probe it using this kit, which is an EIA kit, to probe if there is some enteropathogenic E. coli like the one that hit Germany, E. coli 104H14. So another part of the stool culture is this agar, which is called the Campylobacter agar. And it's pretty much like a blood agar, but it's not. This has a lot of nutrient that will support the growth of Campylobacter jejuni. And one thing different is that because it's microaerophilic, we put it in a bag, that's what you can see, and incubate it at 42 because that is the maximum temperature in which you can isolate this organism better.
So the bag has an oxygen scrubber?
Yeah. It has the right environment for the Campylobacter, the growth of Campylobacter. And so that concludes the stool culture.